Now here we have a Q4 element, and just assume that this is a unit square element. So this is 1 and this is also 1. So in that case, the shape functions for this node would be n1 is equal to 1 minus x into 1 minus y, because when x and y equal to 0, this would be 1. When x or y is equal to 1, this would be 0. Similarly, n2 will be 1 minus y into x, n3 will be xy, and this would be 1 minus x into y. So this is n4, this is n3. In the coordinates given here, this would be the situation. For now, these three nodes are fixed. These three nodes are fixed, and I want to find the position of this node such that determinant of f is equal to 0, or j is equal to 0. Okay. Uh, so what we have to see is what kind of motion does this element with these three nodes fixed, uh, what kind of motion does it represent? So this is a bilinear element. So these shape functions are like this. All these nodes have zero displacement. So ux is simply equal to n3u3 ux3 n3 ux3, and uy is equal to n3 uy3. We already know n3 is xy, so this is ux3 xy, and this is uy3 xy. So this is the motion, this is the displacement, this is the displacement function that this any point inside this element can have, because it's a bilinear element and it has shape functions given by these. Now this cannot move like a rigid body. So if I now take into account the fact that ux, which is equal to u1, is equal to small x1 minus capital X1, then and uy is equal to u2 is small x2 minus capital X2. So then from here we easily find that small x is equal to u x3 xy plus x, and so this is the motion that this element can have. This is the motion that this element can have. Now once you know the motion, now you can get the deformation gradient. So you simply the deformation gradient in this coordinate system would be simply del x del capital X, which would be u x3 times y plus 1. Del x del capital Y would be u x3 times x. This times this derivative with capital X would be uy3 times y, and then with y, capital Y would be uy3 times x plus 1. So this would be your deformation gradient, and this deformation gradient you can now easily calculate the Jacobian, which is determinant of f, and this Jacobian comes out to be this. So there would be values of ux3 and uy3 that will make this Jacobian negative. Think about this. So this, I want this to be 0. This represents a straight line in this xy plane, and this is that straight line. And if this point, this node 3 lies to the left of this straight line, the Jacobian would be negative. If it lies to the right of it, the Jacobian would remain positive. On the line, of course, it will be equal to 0. So this line demarcates the region below which j is less than 0, which means the motion is unphysical.